two masses m and m by 2 are connected at the two ends of a massless rigid rod of length L. The rod is suspended by a thin wire of torsional constant K at the center of mass of the rod mass system. Because of torsional constant K, the restoring torque is tau equals to K theta for angular displacement theta. If the rod is rotated by theta naught and released, the tension in it when it passes through its mean position will be. Let us assume that the center of mass is at distance r1 from mass m by 2 and at a distance r2 from mass m. The position of center of mass xcm will be given by m1 x1 plus m2 x2 divided by m1 plus m2. This position is assumed to be 0 and putting the values we get m by 2 into minus r1 plus m into r2 divided by m by 2 plus m. This gives mr2 equals to mr1 by 2. So r2 equals to r1 by 2. Now the length of rod is L. So r1 plus r2 will be equal to L, which gives r1 plus r1 by 2 equals to L. So r1 equals to 2L by 3 and r2 equals to L by 3. The moment of inertia of this system will be m1 r1 square plus m2 r2 square. Putting the values, we get m by 2 into 2L by 3 square plus m into L by 3 square. This is m by 2 into 4L square by 9 plus ml square by 9, which comes out to be ml square by 3. Now it is given that theta naught is the angular amplitude. And the restoring torque tau is given to be k theta. Now torque can also be written as I alpha, where alpha is the angular acceleration and alpha is equal to omega square theta. So k theta equals to I omega square theta. So omega equals to square root of k by I. Now velocity at equilibrium is maximum and this is equal to omega theta naught. Putting the value of omega, we get velocity to be square root of k by I into theta naught. Now let us see for the mass m by 2. This tension force acts as the centripetal force for circular motion of this mass m by 2. So tension will be equal to m by 2 v square r1. Putting all the values, we get T equals to m by 2 into k by I into theta naught square into 2L by 3, which will be m by 2 into k upon ml square by 3 theta naught square into 2L by 3. So tension comes out to be k theta naught square divided by L. So the answer is option C.